Hello everyone, I'm physics teacher and welcome to my new podcast where I attempt to teach high school physics and chemistry contests to my daughter who hasn't quite reached high school yet. I'll be calling her Coins for this podcast. Say hi, Coins.
Hi.
Be sure to listen to the end to see how she does on our final quiz of 5 questions, which will show me how well I taught her the concept. Each lesson will have a 5-star rating, 1 star for each question she gets right at the end. We'll be making 6 episodes for the first season this summer. If you enjoy it and want a second season, let us know. This is episode 1, where I try to teach her relative velocities. All right, so Coins, let's start with speed. Do you know what speed means?
Yes.
Okay, tell me what speed means.
Super fast,
Okay, so
you go really fast.
Fast is slow, right?
Yes.
Okay, so if I'm driving in the car and you want to look at what speed I'm doing, what do you look at?
The thing that's above the steering wheel.
Yeah, there's like a readout above the steering wheel. One thing is called a speedometer, like speed meter, right? And it will tell you, say, for example, 50 or 60 or 70. And do you know 50 what?
Kilometers per hour?
There you go, 50 kilometers per hour. So, if I were driving at 50 kilometers per hour for 1 hour without slowing down or speeding up, how far do you think I would go?
50 kilometers.
There you go. I'm so glad my daughter could get that. I've seen many people on TikTok do a question like that where so many adults couldn't get that right. All right, so there's our concept of speed. Now, before we move on, I need to talk about 2 types of the things that we measure in physics. One is called a scalar. One is called a vector. So when you say 50 kilometers per hour, that's an amount. So we call that a scalar quantity. Similar to temperature. If you say 20 degrees, and we're from Canada, so we use Celsius, by the way. That's actually hot, not cold. If you say 20 degrees Celsius, that's a scalar. If you give a time, that's a scalar. And now a vector quantity includes direction. So for example, if I were to say 50 kilometers per hour north, that tells you how fast I'm going and what direction I'm going. That's a vector quantity. Okay, we got that? Yeah. I'm not boring you, am I? Maybe I'm boring you a little bit. Okay, so now let's talk about velocity. Have you ever heard the term velocity?
Yeah.
What do you think it means? Hey, do you think it's similar to speed?
No.
Okay. So velocity and speed are somewhat similar, except speed is a scalar, so it has an amount, like 50 kilometers per hour, and velocity includes a direction, so 50 kilometers per hour north. And normally in English, when I say how fast are you going, we only care about speed, right? But if you were to ask someone what's their velocity, you have to include direction, right? And in physics, direction is very, very important. Okay, so let's do a little quiz here. If I were to say 3 hours and 5 minutes, is that a scalar or a vector?
A scalar.
Yes, because it doesn't have
Direction.
There we go. All right, so if I were to say 9.8 meters per second squared down. Don't worry about the square. We'll do that in another lesson. But would that be a scalar or a vector?
A vector.
Yes, because I included
Direction.
There we go. All right. Now, something that's important. Now that we got the basics, we can talk about relative velocity. Relative velocity is interesting. I'm going to start with an example. There's a little story time. When you were very young, you probably don't remember this. You were probably about 5 or 6 years old. I was driving in the car, and you asked me a question. And you said, "Daddy, how come that tree is moving so fast?" Now, unfortunately, now you laugh because you've learned common sense. But you were so much, you had so much imagination when you were a kid.
Are you saying I don't have any?
No, you have lots of imagination now. You're a great artist. But now you laugh at the concept of how fast is the tree going? Why is it moving so fast, right? But when you said that when you were 5 years old, I was so proud of you.
Why?
Because this is the concept of relative velocity. If I'm driving in the car and you're sitting next to me and we look at each other, let's just forget about the fact that I'm driving and I shouldn't be doing that. But if we look at each other, how fast does it look like we're going?
Standing still.
Yes, standing still. But how fast would it look like we're going from somebody standing at the side of the road watching us drive by?
Super fast.
Super fast. So velocity is dependent on who is making the observations. Okay, so when you're in a car and you're driving, let's say you're driving 50 kilometers per hour north and you look outside, it looks like a tree whizzed by you, going backwards. So 50 kilometers per hour south then. If we're driving north, it looks to us like it's moving south. It's going backwards. Right? And there's nothing wrong with that in physics. Right? Because every velocity is relative to an observer. Okay? So, any questions?
No.
Are you flabbergasted?
Yes.
That's okay. Let's try with some examples of relative velocity, and then we're going to move on to our quiz. Okay? So, here's an example. Let's say I'm driving 50 kilometers per hour east. Okay? And there's someone at the side of the road. From their point of view, they see me moving 50 kilometers per hour east. Okay? However, if there is a car driving and it passes me, let's say the car passes me, because it's going from the person on the ground, it looks like it's going 60. So if you look at the speedometers, we're going 50, they're going 60, and they pass us. From our point of view, it doesn't look like they're going 60 kilometers per hour. It looks like the difference, 10. It looks like they're only moving at 10 kilometers per hour. That's how fast they pass us. Does that make sense?
No.
No? Can you imagine going 50?
Yes.
Can you imagine someone next to us going 60, a little bit faster?
Yes.
How much faster?
10.
There you go. So from our point of view, it looks like they're going 10. That's relative velocity. Right? And this is also why police officers, when they have their radar guns, they have to be at rest at the side of the road, because if they were to be driving, right, let's say they're driving at 100 kilometers per hour and you pass them going 110 and they shoot you with the radar gun's only going to read 10, not 110. Right? Because relative to them, you're only passing them at 10 kilometers per hour. So that's why they have to be at rest at the side of the road to figure out how fast you're going. Because all those speed signs on the road are relative to the ground. We call it the ground reference frame.
Yes.
Okay? All right. That's it for our lesson. Let's see how well I did. I'm going to be asking Coins 5 questions, and we'll see how many stars I get. Here we're moving on to the first question. Coins, what is the difference between a scalar and a vector?
So a scalar is like speed or like,
Yep.
you know, just that. And a vector adds that with direction.
There we go. I got 1 star. You got 1 star too.
Yes.
Question 2. Give an example of a velocity. Any example? She's thinking. Give her a minute. Driving at
80 kilometers an hour.
Is that it? That your final answer?
And you look outside and something else is going really fast. Yes.
Oh, I failed. That was a trick. I put that one as a trick, and I will trick my high school students with that one as well. The example of a velocity, you said 80 kilometers per hour, right?
Yes.
Remember, velocity includes direction. Oh, I know. So you would have had to say anything, north, south, east, west, whatever, but you needed to give up if you wanted to. But you wouldn't need to give a direction. All right, that's all right. Question 3. If I'm driving at 100 kilometers per hour north, so imagine I'm on the highway going 100 kilometers per hour north, relative to someone outside on the ground. Okay? Now you're sitting in the passenger seat. Now, how fast does the person outside on the ground see you moving?
Me?
Yes.
Not the car.
Not the car, you.
100 kilometers an hour.
Yes. Right? That's an important fact. So when we're on the highway and we're driving 100 kilometers per hour, you are also moving 100 kilometers per hour. That's why we wear seatbelts. If I were to hit the brakes, that the brakes are going to stop the car from moving, but what's going to stop you from moving?
Seatbelt.
There we go. Wear a seatbelt, everyone. All right, so we got 2 stars. We got that question right. Question 4. Now, same situation. You're still driving at 100 kilometers per hour north, and another car pulls right up next to us and starts driving right beside us. How fast do you see that other car moving?
Like, super slow.
Let's say they're perfectly right
Yeah.
next to us.
You kind of see them just standing. Because we're
Standing still.
moving the same amount.
There we go. I think I can accept that.
Yes.
All right, because their speed from us would be 0. Like they're standing still. All right, we got 3 stars. Last question. This one's my favorite. Okay. We're still driving at 100 kilometers per hour north. Direction's important. You look outside the window and see a tree. From your point of view, how fast do you see that tree moving?
100 kilometers an hour south.
South. Yes, perfect. 4 stars. High five. All right. I hope everyone enjoyed that. Stay tuned for the next episode. And if you have any suggestions, it's our first podcast, let us know in the comments.